Right. Okay. Next, we'll proceed on how to determine the displacement using the velocity time graph. Okay, how do we determine displacement using velocity time graph? Give you a straightforward response. Displacement equals area under VT graph. Alright, area under VT graph. Don't be confused by the word area because that's just determining using the shape of the graph. It's not moved by the object, it's just the shape of the graph. Right? Area. So we're going to be more specific. Right? We're not just going to say displacement. We're going to find displacement between 0 seconds and 0 seconds and 8 seconds. Right, between 0 seconds and 8 seconds. And for displacement between 0 seconds and 8 seconds, we must first map out the coordinates. Okay, so when we talk about area under VT graph, right, we are talking about between the graph and the time axis. So you'll be between this and this. Okay, the one I highlighted in, I draw in orange, right? Between these two lines. And from 0 seconds to 8 seconds. That is here. So we are interested in this. We're interested in this area. This, if you calculate this area, so when we say area under VT graph, so this area will actually tell us the displacement traveled by the moving object. I erase this for clarity. Right, area under velocity time graph. So that's what it means. Right, again, do take note, you're not finding the area of the moving object. No, the area under the graph gives you the displacement by the moving object. So the area under the graph, what you saw just now was a right angle triangle. I say again, what you saw just now was a right angle triangle. Okay, you saw a right angle triangle. And how do you find the area of the right angle triangle? Half base times height. So from 0 to 8, that's 8 seconds. From 0 to 4 meter per second, that's change in 4 meter per second. So area under VT graph, half base, that's 8 seconds, times height, 4 meter per second. So you get half, I write down 8 seconds, and I write this 4 meter over 1 second. Okay, and this, you don't have to really write this I'm showing here, because I just need to show you how the unit is derived. So second, I just cancel it, and what I have is 16 meters. So displacement between 0 seconds and 8 seconds, displacement is 16 meters. Right? I say again, not square. Don't go and square it. Right? 16 meters. Okay? Right. Now, this is a simple right angle triangle. Now, what happens if you don't get a very nice shape like a right angle triangle, or you don't get a very nice shape like a rectangle or a square? What happens? I'll show you there are a few ways of solving it. Let me erase the details here first. Now, what happens if you're asked to find the displacement between 4 seconds and 8 seconds? Right? The underlying concept is still area under VT graph. So you still know it's this area, right? You still know it's that area. Okay. So I'm going to show you two methods. Method 1, right? Find the area of the trapezium. Area of trapezium over here is 8 minus 4 gives you 4 seconds. Over here you have 2 meter per second, and here you have 4 meter per second. Alright. So area of trapezium, half the sum of parallel sides times vertical height. Okay, and then you get 12 meters. Sorry, I'll just show you step by step. Half 6 meters per 1 second, 4 seconds, cancel, you get 12 meters. So method 1, you can just use the area of a trapezium. Alright? But you see, notice I emphasize is area under VT graph. Notice I don't talk a lot about what kind of shapes they are. I keep focusing on area under VT graph. So that means there's another method which I think some of you could have seen it, and that is here, this point. And over here, the velocity will have increased from 2 to 4. That gives you 2 meter per second. And the velocity below will be 0 to 2, and that gives you 2 minus 0 equals 2 meter per second. So what you get is area of a rectangle plus area of a triangle. And the area of a rectangle will give you 2 meter per second times 4 seconds plus half times base times height. This 2 refers to this one, and this 2 refers to this one. Okay, by now you should get an idea of how I cancel out the units, so I'm just going to dive straight into the answer. So that give you 8 plus 4 equals 12 meters. So you see, using another method, you still can get the same displacement. So the very basic idea is still area under the VT graph. Right, area under the VT graph. I'm going to show you another method. Method 3, that should be the final one. Method 3, okay. Now in order to show you that method, I need to erase everything else because the graph is getting too congested. Okay, by now you should more or less get the idea. So I'm not going to use the digital ruler. I'm just going to draw with my free hand. By the exam, please use the digital ruler. Please use your ruler. Again, we are interested in this area. Alright, again, area. Okay, so what we can do next is find the area of a rectangle. Find the area of the whole rectangle and minus off that triangle. This is 4 meters per second. So from 0 to 4. This is 4 to 8. So 4 seconds. Alright. So this will also put it at 4 seconds. And this part here is actually 2 to 4. So 4 minus 2 equals 2 meters per second. So the third method, what we can do is to take area of rectangle minus area of triangle. Okay, take the whole area of rectangle minus area of triangle. Area of rectangle, I have 4 times 4. I'll show you the two different 4s. This 4 is taken from here. The other 4 is taken from here. Okay, hope it's clearer. Minus area of triangle, half base times height. Okay, I'm running out of colors. This 4 is taken from here. Okay, there's only 1 2 there. Alright, so we have 16 minus 4, and that'll give me 12 meters. Okay, so I've shown you 3 different methods, 3 different proof that your focus should be area under velocity time graph. Okay, be confident about it. I think all you need is just familiarization.